Okay, today we're going to talk about the chapter 1, Origins of Exercise Physiology, Foundations for the Field of Study. Some of the objectives in this chapter, we're really going to look at Galen's contributions to health and science, scientific hygiene, beginnings of development of exercise phys in the U.S., contributions of George Well Fitz to the evolution of academic field of exercise phys, some of the major contributions of Nordic scientists to the field of exercise phys. We're going to outline the course of study for a first academic 4-year program in the U.S. from the Department of Anatomy, Phys, and Physical Training at Harvard University. Describe the creation of the Harvard Fatigue Laboratory, its major scientists, and its contributions to the field of exercise phys. Look at the jobs of an exercise physiologist. Discuss the role of social networking, how these would relate to exercise physiologists. And then the two most prominent exercise physiology professional organizations. Exercise physiology consists of three distinct components as an academic discipline. It's a body of knowledge built on facts, theories derived from research, formal course of study, an institution of higher learning, professional preparation of practitioners, future investigators, and leaders in the field. And this really emerged from the influences of several traditional fields, primarily anatomy, physiology, and medicine. Origins of exercise physiology. We have individuals here who were the earliest development from antiquity. You have some individuals who, such as these Greek physicians, Herodotus, Hippocrates, and Galen, who were influential in regards to what exercise was and what it did to the body. Okay, so basically we had individual Herodotus, who was a physician and athlete, strongly advocated proper diet, physical training. His early writings actually influenced Hippocrates, who was the father of modern medicine, who first wrote about preventative medicine. He actually was the individual who, in medicine, they came up with the Hippocratic Oath, which is the sort of uphold specific ethical standards to do no harm. And he had about 87 treatises of medicine, including several on health, hygiene, during the influential golden age of Greece. 5 centuries after Hippocrates, you had Galen, who basically emerged as one of the most influential early physicians, son of a wealthy architect. And he talked about the laws of health, which aren't uncommon today. And these are stated next here. Galen really emerged as the most well-known influential physician ever lived. Wrote 500 essays on human anatomy, physiology, nutrition, growth and development, benefits of exercise, deleterious consequences of sedentary living, and diverse diseases and their treatments. He actually introduced the concept of polysarchia, which is now called morbid obesity, and proposed treatments commonly used today, which are diet, exercise, and medications. It's interesting because he spoke about how, in practice, the 7 laws of health, which are breathing fresh air, eating proper foods, drinking the right beverages, exercising, getting adequate sleep, having going to the bathroom daily, and controlling one's emotions. He also used various surgical procedures to treat torn tendons, muscles ripped apart in combat, and formulated rehab and exercise regimens, therapeutic treatment for dislocated shoulders. Okay, so he was really, really influential. Growth in the United States. Before 1800, there were 39 first edition American authored medical books and one medical journal. By 1850, so 50 years later, the journals increased to 117. Hot topics were nutrition and dieting, exercise, how to develop overall fitness, training, exercise, and recreation and preparation for sport, and personal health and hygiene, which is interesting because in 2020, these are some of the hot topics as well. It's funny how hundreds of years have passed and these are still hot topics. So by the mid 19th century, medical school grads basically began to assume positions of leadership in academia and allied medical sciences. And okay, Austin Flint Jr. Okay, so we'll first discuss him and what he basically did. He was a medical doctor who contributed significantly to the burgeoning literature and physiology, fostered belief amongst 19th century American physical education teachers that muscular exercise should be taught from a strong foundation of science and experimentation. And then, okay, so what would that be versus? Well, that's versus personal opinion and anecdotal evidence, which may not be research based, okay, or objective. He actually served from 1861 to 1897 as the New York State's first Surgeon General. So this individual was a pioneering American physician physiologist. Very interesting. He was trained in the scientific method, and did a lot of things in regards to the heart. So he had an American Medical Association's Prize for Basic Research in the Heart in 1858. So this individual was influential, very influential. Another individual who's basically not listed on here is an individual called Ethne Jules Marie. Ethne Jules Marie was an early cardiograph. Created the early cardiograph, basically registering waveform and frequency of the pulse for his spiromograph, and basically it's an instrument that it takes down basically the heart rate, okay, from the pulse. It's pretty interesting. It's on page 8. Edward Hitchcock and Hitchcock Jr. These are two individuals that father and son who pioneered American sports science movement. Hitchcock was first to statistically record basic anthropometric data in large group of subjects. Hitchcock co-authored Anatomy and Phys book geared toward college physical education. And what they measured, which is actually on page 11, they measured things such as girth, height, breadth, lengths, indices of muscular strength, and lung capacity and pilosity, which is hairiness, actually. Pilosity is how much hair, body hair. These individuals they also used a spirometer to measure respiratory function. So both of these individuals were highly influential in regards to anatomy and phys for the physical education student. Okay. We have next here. Okay, the father's on the left and the junior is on the right. Interesting information considering must be a much later picture, obviously, of junior. George Well Fitz, MD. This is an individual who basically was influential in the. He was a physician and pioneer exercise physiology researcher. Helped establish the Department of Anatomy, Phys, and Physical Training at Harvard University, 1891. Developed the first formal exercise phys lab where students investigated the effects of exercise on cardiorespiratory function, including muscular fatigue, metabolism, and nervous system functions. Interestingly enough, on page 12, The course of study of the Department of Anatomy, Phys, and Physical Training, Lawrence Scientific School at Harvard University, which this individual was instrumental in creating, the core courses from year 1, 2, 3, and 4 are listed there. And the strong science background that you had to have be in this uh, physical education program was pretty tough. I mean, there was zoology, physics, histology, looking at tissues under a microscope, uh, and other things, forensics, medical chemistry. So it's pretty tough, the first phys ed degree program. So Harvard's Department of Anatomy and Physiology Physical Training. Okay, so we're talking to about this, and what we're saying about this is that so what did it do? So what did this department basically in this physical education major focus on? They're focused on preparing students with or without subsequent training in medicine to become directors of gymnasia or instructors in physical training. Provide general knowledge about science and exercise, including systematic training to maintain health and fitness, and provide suitable academic preparation to enter medical school. So these individuals were, it's kind of interesting, right? It's a broad spectrum of what you could go into: physical education, directors of gymnasia, instructors in physical training. Oh, and also medical school. So, I mean, you had to be really competent in a lot of these different areas, which, yeah, it would be difficult today to take some of these courses. A prerequisite, by the way, of Fitz's exercise phys course was general physiology, or its equivalent, taking at the medical school. So his physiology of exercise course basically introduced students to fundamentals of physical education, providing training and experimental methods related to exercise physiology. Okay. And there are other individuals, by the way, in this chapter you need to go back and look through to see who made contributions, not just the individuals in here. There are a few others, such as Claude Bernard, and a few others. Dudley Sargent, he dealt with the physics of biological moving systems. And so that would be a good idea to go back through and look at some of these individuals as well. Exercise Studies and Research Journals. So in 1898, there was 3 articles on physical activity appeared in the first volume of the American Journal of Physiology. The Journal of Applied Physiology contained a classic paper by J.M. Tanner on the ratio expression from physiological data with reference to body size and function. Okay. Another exercise study and research journal, Journal of ACSM. The ACSM is American College of Sports Medicine and Sport and Science and Sports. First appeared in 1969. Aimed to integrate both medical and physiological aspects of sports medicine and exercise science. This changed in 1980 to the Medicine, Science, and Sports and Exercise Journal. First textbook in exercise physiology. On page 15 in your book, it talks about debate exists over what was the first textbook, Exercise Phys. To deserve such a historical recognition, what should a textbook include? Well, it needs to have a sound scientific rationale for major concepts. Okay, so were the concepts, did they actually follow a methodology that was research-based? Did they provide summary information based on experimentation about important research in a particular topic area? They provide sufficient factual information. So were they factual enough to give it the book that is academic legitimacy? Okay. So those are some of the questions that have to be asked whenever a textbook in a certain discipline is valid. So first textbook. Okay, here's a couple candidates. Combs, 1843, Principles of Physiology Applied to the Preservation of Health to the Improvement of Physical Mental Education. Hitchcock and Hitchcock, father and son, 1860, Elementary Anatomy and Physiology of Colleges, Academies, and Other Schools. Kolb, 1893, Physiology of Sport, and Martin, 1896, Human Body, an account of its structure and activities and the conditions of its healthy working. So these are the ones that they're up for analysis on which one was the actual first exercise physiology book. Fast forward a little bit here to we have contributions of the Harvard Fatigue Laboratory. So you see that it's 1927, and you say to yourself, well, wait a second, I thought it was 1893 when they came up with this at Harvard, the program, the PE program. Well, basically 27 years after Harvard closed its first exercise physiology laboratory. So they closed that, the one that was around in 1893, they closed it. So 27 years later, okay, so they closed the other one around 1901, 1900, and they came up with, they reopened, there was a Harvard Fatigue Laboratory that was created. It legitimized exercise physiology as an important area of research and study, and established Lawrence J. Henderson, MD, Harvard chemist and professor of biochemistry. He basically established this. The director, first and only scientific director of the laboratory, was David Bruce Dill, a Stanford Ph.D. in physical chemistry. So interestingly enough, we're looking at the chemical basis of exercise physiology, which is interesting because it is chemically based and also biologically based. So what did Dill do? Basically, he looked at biochemistry and experimental physiology to become the driving force between the laboratory's numerous scientific accomplishments. Basically, they wrote a book. The co-author was Dill in 1931, which is Physiology of Muscular Activity. Okay, so they continued on with these types of the Harvard Fatigue Laboratory basically continued on with a lot of the research that was important in the area of study. One of the individuals too that's kind of missed in the PowerPoint is another guy named Franklin Henry, by the way, who was at Cal Berkeley, who was the father of motor development. He was another individual who was a physical educator and psychologist who first proposed physical education as an academic discipline, by the way, and that's on page 16. He dealt with oxygen uptake, kinetics during exercise, recovery, muscular strength, cardiorespiratory variability during steady state exercise, and things like that. And also neural control in regards to human motor performance. So moving on from Franklin Henry, we have a Nordic connection too in regards to exercise physiology. We have Johannes Linhard, okay, and basically Linhard was a medical doctor, teamed with August Crow, Ph.D., who was basically listed. It was a Nobel laureate as who was basically titled as the ultimate exercise physiologist, who specialized in physiological chemistry, designing many classical experiments. Basically, Linhard and Krogh investigated gas exchange in the lungs. So they dealt with the CO2, O2 gas exchange, which basically just dealt with how did these two chemicals, you had the elements, of oxygen and carbon dioxide. How did they diffuse? How did they go across the alveoli? And so, in regards to these two individuals, they did a lot in regards to contribution of fat and carbohydrate oxidation during exercise, measured blood flow redistribution during different exercise intensities, and quantified cardiorespiratory dynamics in exercise. Interestingly enough, and I'll mention this individual because I think it's equally important, is Marie Jorgensen Krogh, Krogh's wife, and she was the one that helped with the respiratory gas diffusion across the thin pulmonary membranes, which are the alveoli. So she was a part of it, the research as well. Um, they figured out that basically this gas exchange of carbon dioxide and oxygen happened through diffusion and um, not secretion. Okay, which was back at in the time that was pretty notable. Okay, so moving along, uh, we have Swedish influence, and so that there with the Crow, he and his wife is on page 17. We have the Swedish influence, which is per Heinrich Ling, who was the director of Stockholm's Royal Stockholm's Royal Central Institute of Gymnastics. Ling, in addition to his expertise in exercise and movement, developed a system of medical gymnastics, which incorporated studies of anatomy and physiology, which became integral to Sweden's school curriculum in 1820. Ling's son, actually, Halmar Ling, published an important textbook about the kinesiology of bodily movements. Kinesiology is a study of human movement, so just so we know about that too as well. Per Heinrich Ling and his son basically were pioneering influences in physical education. These individuals were influential as well in the exercise science, exercise physiology realm. Moving on to Per Olof Astrand, MD, Ph.D., most famous graduate of the Swedish College of Physical Education. Swedish College of Physical Education is basically, he was the most famous individual to graduate from it. He did his doctoral thesis at Karolinska Institute of Medical School, taught in the Department of Physiology, College of Physical Education from 1946 to 1977, served as professor and department head, and evaluated working capacity of men and women aged 4 to 33. So basically, they looked at physiological, he and Christensen, another individual, looked at physiological responses to intermittent exercise. And also they led to scientists at the Karolinska Institute too, looking at two other individuals, Bergstrom and Holtman, looked at the first needle biopsy of the vastus lateralis, muscle fiber composition of type 1, type 2, things like that, which we'll talk about later. Norwegian Finnish influence. We have prominent Norwegian researcher Lars Hermansen, got the ACSM Citation Award in 85, which means he had high amounts of citations on papers, contributions. One of the studies titled in 1969, Anaerobic Energy Release, appearing in Medicine and Science and Sports. And then another individual, Marty Karvonen, who he's MD, PhD, who basically came up with a method to predict optimal exercise training heart rate called Karvonen method. Published combined areas of exercise physiology and sport biomechanics. There's others too on pages 20, 21 that have done other things too as well, that notable influences that are really that that should be looked into. One of the individuals actually worked with Roger Bannister, who shattered the sub 4 minute mile barrier. So he ran a mile in under 4 minutes, 1954. Okay. Let's go here. Exercise Phys in the World Wide Web and online social networking. Publications applied basic exercise phys research has increased in the field, expands different areas. So the field has increased. Okay. It's had much growth. If you do a Google search, you'll have a high amount of information given to you. In 2015, there was 4,590,000 hits for the term exercise phys. Okay, if you add muscle, it drops it down to about 1,660,000. But if you look even closer at DNA, muscle, and twins, it drops it down to about 500,000. So the internet provides a great repository for information, okay, to focus on things. When you drill down though to certain topics, when you look at something that's pertinent and also more importantly reliable, which obviously is the primary thing you should be looking for, you need to be looking at places like PubMed, okay, NIH, things like that, okay. So there's a lot of growth and potential for information dissemination in this area, social networking. You have to be careful. You look at some of these things like Instagram and this and that, and even information on just boards, certain boards. You have to make sure that what you're getting is objective, reliable, valid information. Okay, so you want it to come from a reputable source or reputable sources. Organizations, American Association for Advancement of Physical Education, formed 1885. First professional organization in the U.S. to include topics related to exercise phys. Predated American Alliance for Health, Physical Education, Recreation, and Dance. AFERD. Okay. AFERD is now SHAPE. However, in regards to, until about the 1950s, AFERD was the disciplines organization, as in the exercise physiologies organization, until about the 1950s. And they split from physical education. They split from AFERD, and they really went their own direction. And that's why they now, really, American College of Sports Medicine, ACSM, 20,000 members, 75 countries, largest professional organization for exercise. Another one basically is the NSCA, which is the National Strength and Conditioning Association, which is another organization that has prominence in the exercise physiology world. Really, those two are the ones that they're of prominence. NSCA has their certification, which is the one, the Certified Strength Conditioning Specialist, the CSCS, and ACSM has the Exercise Physiology Certification, the EPC, which are the two certifications that are ones that are coveted. What do exercise physiologists do? Some use the research skills primarily in colleges, universities, private industries. Others are employed in health, fitness, and rehab centers. Others serve as educators, personal trainers, managers, entrepreneurs, health and fitness industry. So in all reality, the question is where are you going with the degree program? If you get a degree that's specific in exercise physiology, some individuals may have a degree in exercise physiology, but it also can apply to an exercise physiologist can also apply. The term can apply to individuals with adequate academic preparation. There's no national consensus as to what constitutes an acceptable minimal academic program of coursework in exercise phys. That's why I said that sometimes the certifications of EPC from ACSM or CSCS from NSCA are looked at as having some type of objective measure. So basically, lab experiences. There's no university standard for lab experiences in anatomy, biomechanics, or exercise phys for any type of level of competency. So it's just information, a lot of it that you're getting in an undergraduate program if you were primarily just an exercise phys major. So it's very broad information in the field. Okay. What do the exercise physiologists do? Okay, so some of them basically there's diverse fields. You can go into health, fitness, and rehab. You can go into become an educator, personal trainer, manager, entrepreneur in the health and fitness industry. You can become a sports director, strength conditioning coach, consultant. I mean, one of the things is that some exercise physiologists actually they go into cardiac rehab. They become working cardiac rehab offices with physicians and do heart and vascular stress tests, dealing with basically treadmill stress tests, and work with patients that have cardiac and pulmonary diseases. They have to in this cardiac rehab job, position, they basically have to look at patient medical records, exercise and pharmacological stress test supervision, uh, be able to look at static and dynamic ECG or electrocardiogram, PQRST, trend line data that comes basically from the heart rhythm, and also systolic, diastolic changes in blood pressure and things like that during these stress tests. Some of these jobs you need a master's degree in exercise phys, nursing, things like that, and some of them want you to have the ACSM certification, EPC or NSCA's CSCS. Some of these places you have to be able to do a 12-lead ECG interpretation and arrhythmia recognition from the PQRST line. So there's a lot that you basically may possibly have to do on top of what you're doing with an exercise physiology just degree. In the clinical setting, they can work with physicians, dietitians, nurses, physical therapists, occupational therapists, and things of that nature as well. ACSM certifications, you have health and fitness track, exercise leader, health and fitness instructor, health fitness director, clinical track, exercise test technologist, preventative rehab, exercise specialist, preventative rehab program director. These are some of the ways that once you get these certifications, you can go in these directions.